Okay, today is November the 5th, 2017, and right now at 9 p.m. we have a temperature of 52 degrees in the foothills of Los Angeles. The relative humidity is 82%. The dew point is 47 degrees, and the barometer is reading 30.07 inches. All right, so we're looking at the rainbow map, the infrared map for the Northeast Pacific, and we can see that there is a tropical flow pattern moving right towards Southern California, in addition to a low pressure system right here, which is also moving into Southern California. Let's take a quick look right now at the jet stream map, so we can all see what's going on. Here is the 300 millibar jet stream map, and we have high-speed flow right into Central and Southern California, indicated right here. We also have some high-speed flow around a high-pressure system, which has been installed out here near the Central Pacific to block a couple of low-pressure systems. We'll take a look at that. Let's go back to the next. Let's take a look here real quick at the Doppler map. This is the Intellicast Doppler radar map, indicating where the precipitation is happening around the country. And we can see that there's really no precipitation, no rain in the Central and Southern California area. There is some offshore, and if we zoom in real quick and take a look at that, if I can get this map to work, we can see that the area offshore of California is actually being chopped up by one of those WSR 88, I believe it is, or WSR 88D microwave Doppler radars. We can see that right here. Everything is chopped up, and if we triangulate this activity, it all points right to that transmitter on right near Vandenberg right here. Everything here, if we just zoom in and look at the pattern, this all points right to the transmitter there right near Vandenberg Air Force Base. Okay, so no rain in Central or Southern California all weekend. We had, like I said, there was a little bit of dew on the ground this morning. Let's look now at the Northeast Pacific water vapor loop. We can see that jet stream flow moving in, and yet we have zero rain on that Doppler map. See that here again. We have in the rainbow map here, we can see all that flow right into Southern California. Let's take a look here at the next series of maps. Let's refresh that one. Come back to that here in a second. Here's the Southwest water vapor loop. We can see that high-speed flow, the jet stream flow moving right into LA, which is right there. And yet we have zero rain anywhere in Southern California. Here's the IR map, the rainbow map for Southern California. None of this is producing any rain, so we've got chemtrails being sprayed. We can see that here in the SSEC Watervapor map right here. See that low pressure system sitting offshore, moving right towards Central and Southern California. We can see the chemtrails being sprayed right in this tropical flow right here. All this is moving right into Baja and Southern California. Notice what's happening right down here. I'll get the camera. Let's see if I can capture that. The contrast on this camera is not very good, but this area of thunderstorms right here is being blown apart, and we can see the blast pattern right there. Now, a lot of the frames on this 56 or 48 hour, or rather this 48 image loop, have been taken out because they were blacked over. Half of the image was blacked over, so I had to remove several, probably about a dozen images. But right down here we see a area of thunderstorms right here being blown apart. This is obviously a disturbance of some sort, which they didn't want to form into a storm and get caught up in this flow pattern right into the southwest. So that was neutralized. That's very obvious to see what happened right there. Let's take a look next at the surface analysis map. And we can see that right offshore, that counterclockwise spinning area of low pressure is right here, indicated as a low pressure, with a trough right here, moving right towards California, central and southern California. And we have this high pressure installed right here, which is blocking this developing gale right here, and also a developing storm, a rapidly intensifying storm, which has a central pressure of 1001 millibar. Okay, so let's go back to the big map again and take a look at what's going on. Got this low pressure system right here, which is moving right in on the jet stream, and yet we have zero rain. All day long, the humidity was right around in the 60% range, 50 to 60%. I've had a headache most of the day, and I think that is because of the offshore chemtrail spraying going on. Actually, I've had a headache for on and off for the last 3 days. And look at here, we have high pressure right over the islands, as this is a gale right here, and this is a developing storm right here. There's actually 3 lows. We've got one right here as well. I think you only showed 2 on that surface analysis map. Anyhow, this high pressure will set up and block all of this weather. We've got a dark area starting to fill out right in this area of the East Pacific. And we can see all that evaporation as that high pressure sets up to block all this moisture moving towards the west coast. We can see that here. There's a large channel of big void there. There's no water vapor. But this is amazing here. We've got an opportunity for rain, and that's all being stopped. So these weather controllers offshore must be spraying very intensely to stop that opportunity. You can actually see some spraying going on right here. Look at all the evaporation taking place here as this clockwise area of high pressure sets up. That is done purposely. They've got high pressure right in this area. That's evaporating all this moisture as it moves down towards the west coast. Okay. Now, in the last video, or a couple of videos back, I was talking about saturating rain, and the last time that we've really had a lot of rain here in the foothills. And so I dug out my records, which right here at my location here now only go back to 2009. And so I'll have to go back into my other records, which go back into the 80s. We have annual records for rainfall going back into the 80s. So I'm going to dig those out, but just for right now, we have some interesting numbers. In 2009 and 10, that season, we actually had, let's take a look here, we had between January 18th and January 22nd, on the 18th and 19th, we had 3 7/8, and then on the 20th, the next day, we had another 3 5/8, following right through the 22nd, so we had another 3 inches. So from the 18th of January through the 22nd, we had over 6 inches. In fact, 7/8 and 5/8. That's over 7 inches of rain, 7 1/4, 7 1/8, somewhere in there, just in those few days. That was back in actually 2010. This is January 18th through January 22nd. So that was for the year 2010 and the 2009 and 10 season. Next, we have the 2010 and 2011 season. On December the 17th through the 19th, we had 5 1/4 inches. That was in 2010, very end of 2010. 5 1/4 inches on December 17th through 19th. That was Another year where we had 28 inches, 28 3/4 inches that year. And then the following March 2011, we had 5 1/8 inches on the 19th through the 21st of March. 5 1/8 inches. All right, so these are interesting numbers because as we move through to the next significant rain event, which was the year 2013 through 2014, that year, which was one of the driest years we've ever had, we had 7.59 inches that year. That's where we really started to notice the drought in 2013 and 14. Now that year, on February the 28th through March 1st, that's 2 days, because that was not a leap year, so we jumped from the 28th to March 1st. We had 5 1/4 inches that day on those 2 days. And that was 2014, February 28th, and the following day, March 1st. In 2014, we had 5 1/4 inches. And that was the only significant rain event that entire year. And as I mentioned on these previous two seasons, going back to 2010 and 11, once again, we had one significant, or actually 2 significant rain events, December 17th and 19th, 5 1/4 inches, and we had another event, March 19th and 21st, 5 1/8 inches, and that was 2010 and 2011. Now, 2014 and 2015, we had the most significant rain we had that season was December 11th and 12th. We had 2.49 inches. All right. That was, and then we had another 2 1/4 inches on February 22nd through March 2nd. So there were several days in there which we had little bits of rain, and that all totaled up to be 2 1/4 inches. All right, so the point I'm getting at is that the rainfall has really tapered off in terms of the intensity. If we go back to these earlier years, we see that we have 2 or 3 days where we really get a lot of saturating rain, and that's what the trees and the bushes and everything really need. The plants, we need saturating rains which penetrate the soil, and we're not getting that anymore. And that's why I'm reading these numbers off, because this trend really shows up. And again, these numbers, these points, these important points, are not analyzed or mentioned by these meteorologists reporting the weather on television. All right, so now this last year, we had most of this rain that we had was right around January 9th through the 12th. We had a total of, let's see here, we had 3.15 or 3.16 inches. That was the most significant rain that we had this last year, which, by the way, was where there was a lot of rain in Northern California. That's what broke the Oroville Dam, which is almost finished with the repair work. That spillway had to be completely torn up and rebuilt, and they're almost finished with that. So again, we see the trend show up that in all the rain that we had this last year, 2016 and 17, for a total of 21.8 inches, the only significant rain was saturating rain, which was 3.16 inches. That was on the 9th, 10th, 11th, and 12th. All right, so that's the report. We'll just keep the reports coming when we have the time to do them, and we'll just leave it right here. We've got the jet stream flow right into California and no rain. Once again, we'll show that Doppler map. Look at that. There's nothing there. It's all being microwaved offshore. There it is. You can actually see a return there. They've broken up all that rain, and we can see that right there, all of that evaporation. Okay, that's it.